Bismillahirrahmanirrahim. Today I wanna configure IPsec over GRE tunnel that as you watched my last video that how can we create GRE tunnel, and today we want to protect that tunnel. As you know better that the GRE tunnel is not by default protected. So for protection of this tunnel, we can use from IPsec or Internet Protocol Security. So what is Internet Protocol Security? Internet Protocol Security is a set of protocol developed by IETF or Internet Engineering Task Force. That's a standard committee that's developed by this committee. So what's the usage of IPsec? IPsec allow two or more hosts or nodes that communicate in a secure manner by authentication and encryption. Uh, uh, each IP packets of communication session. IP security services features, or what's the IP sec services or IPsec features. IPsec features are as follows. That's data origin authentication. What's this? The data origin authentication exchange made the data or done only by unauthorized individual users or system. Which algorithms are used in this authentication? Those are HMAC MD5, HMAC SHA-1, HMAC SHA-2. And the other one is data integrity. That is the data integrity is used for the accuracy of data, that data should be accurate. And the other one is data confidentiality, that only authorized person or system can view sensitive or classified information. No can has rights to visit or access those data. Which algorithm are used for this uh, for protection of data? That's DES, 3DES, and AES. These are used for protection or encryption of data. And the other feature is anti-reply, ensuring packet received only once. And security service can reject all or duplicate packets in order to defeat reply attacks. That's very important. That one of the main and one of the very important feature of IPsec protocol is anti-reply function. And the other one is key management, secure key negotiation across non-secure transport. So here two uh, key managements are used for this function, the IKE version 1 and IKE version 2 of Internet Key Exchange version 1 and Internet Key Exchange version 2. Define the negotiation of IPsec tunnel and encryption keys. So right now we want to discuss on that which steps we should follow that apply IP6, or which are the steps for configuration of IPsec protocol. These are 5 steps. The first one is entrusting traffic. The entrusting traffic is very important. Uh, in this case, we want to specify our targeted traffic that we want to implement this security protocol on that, and we want to protect this traffic on both sides. And the second step is implementation of IKE phase 1 or Internet Key Exchange phase 1. In this section, the secure channel is created. And the third phase is or steps or IKE phase 2. In this steps, the data is protected by IP security policy. And the fourth step is data transfer, apply secure service on traffic, and then transmit the traffic to the other side. And the final one is tunnel terminated. Tunnel is turned down and the communication is terminated. So right now we wanna configure IPsec on GRE tunnel. That before we created that tunnel with this topology, as you know, we created a GRE tunnel between site A and site B in our last video, and today we want to implement IP security on this tunnel. The source and destination is also cleared in this topology. The source is 172.168.0.0 from site A, and the destination is 192.168.0.0 from site B. And site B source is 192.168.0.0 and the destination is 172.168.0.0 from site A. In this case, our entrusted traffics are 172.168.0.0 and 192.168.0.0. So in this case, at the first time, we should create an access list and we should define this traffic on that access list, our source traffic and also our destination traffic. So in this case, how can we create an extended access control list? At the first time, I should configure that how can we create access list. I'm coming to router 1, and in this case, I wanna create a extended access control list for specifying my source and destination traffic. So I'm coming here, and this is my router 1. At the first time, I should know the IP address of my router 1 interfaces. So IP interface B, pipeline, exclude, and assign. Okay, my LAN or my internal network subnet is 172.168.0.0, and this interface is directly connected with my LAN network, my local network. So this interface IP is 172.168.0.1 and serial 1/0. This interface directly connected with my ISP router. The IP of this interface is 100.1.1.1. The other side of this interface is 100.1.1.2. At the first time, I should test the ping. My other side. Okay, I'm connected to my ISP router, this interface. Also, I want to check the communication between router side A and router side B. I want to ping this interface. This interface IP is 200.1.1.2. Okay, I want to test. Okay, I'm connecting with that. So my communication is established, and also I configured GRE tunnel. You can see my tunnel is tunnel 0. Okay, and also I can ping site B internal network as well. For example, ping 192.168.0.1. Okay, the 0.2 is the host. Okay, I can ping this PC. Also, I can ping this PC from this PC. I'm coming to PC1 and ping 192.168.0.2. Okay, the communication is established. So right now, when this traffic is going from this PC through this tunnel and arriving to this PC, this traffic is not secure. This traffic is right now not secure. This traffic is going through this tunnel. This traffic is not secure. So for security of this data or this traffic, for protection of this traffic, we should apply IPsec over GRE tunnel. Okay, right now we should specify the steps. At the first time, I'm coming to router 1 and creating extended access list for specifying my traffic. I'm coming here, global configuration mode, and type access list 110 permit IP 172.16. That's my local subnets, and this is wildcard mask, my destination, and wildcard mask. I specified my traffic and through this access control list. This is my source and this is my destination. Mean if a packet is going from this subnets to this subnet, that should be protected. And I'm coming to the router T as well. Show IP interface brief. Exclude unassign. My internal network IP is this, or my internal network subnets 192.160.0.0. This interface directly connected with my LAN. So the source is this subnet and the destination 172. I also create access list here. Permit 192.168.0.0. Destination 0.55. The entrusted traffic is selected. Right now I am coming here and create the first step or first phase of IPsec by crypto IPsec policy 10. Maybe you should add a number from 1 up to 10,000. Authentication, share, encryption. You can specify the encryption method or algorithm. Here I specified AES, number of bits 255, hash group 5. Now I'm going to create a key. For that, crypto IPsec key 0. The key is score 123. Address, destination addresses 20.1.1. This interface IP. Which interface? This interface IP. The destination for site A router is this interface IP. Okay. And also I'm coming to phase 2. The phase 1 configuration is done, and in this session the secure channel is created. Right now I'm coming to configuration of phase 2 crypto, and I am going to configure transform set crypto IPsec transform set. Maybe you should add a name for that. Maybe KBL. Okay. You can set the types of transform cipher, ASP, AES 255, ASP, SHA, and also you can specify here the tunnel mode. Maybe mode, we have two types of tunnel, transport, we have two types of mode, and VPN tunnel, transport mode and tunnel mode. I specified mode. Right now I am going to create a map. Map. a number IPsec now add your access number. Access number is 1110 that you can specify before. Match your access list number here. Okay. Set the peer address. Set the peer addresses for me 20. Okay, destination. Physical address. Physical interface address of my site B. That's directly connected with ISP router. Also set transform set. What's the name of transform set? Is career. Okay. You can add description as well. For example, protecting secure channel with site. After the configuration of phase 2, IPsec phase 2, right now I'm applying this map on interface. Which interface? Physical interface or tunnel interface? I should apply this map on tunnel interface. Okay, I'm coming and I'm entering to tunnel interface. The number of tunnel is 0. So for applying, you can add crypto map. What's the name of map? Cisco. Okay. Right now, the ISAC MP is implemented and on in this tunnel. Exit. Done in router 1. I should configure the same configuration on my side B router. Which router? This router. Coming here and configuring. Okay, the first time I should create access list. Installation is now it is time for verification. Come here. At the first time, I should see show IPsec. Okay. the encrypted encapsulation and decapsulation is not okay right now, and the packet is not encrypted right now because the packet is not coming or going through this tunnel right now. The packet's encapsulation is 0, decapsulation is also 0, encryption is 0, and also decryption is also 0. The packet digestion is also 0, verification is also 0. For this test, I wanna check this tunnel, that when I'm communicating with side B, or when traffic is coming from side A or from my LAN. Suppose this is my LAN, this PC is connected to my side A LAN, and the traffic is coming here through this tunnel. Is this packet is encapsulated or encrypted through this tunnel or not? This right now the IPsec is configured over this tunnel, and right now when packet is coming from this PC and going through this tunnel, this packet is encapsulating and encrypting through this tunnel and coming to this PC, or this PC is connected with side B LAN. Okay, in this case I should ping the my destination from side A. I ping side B, and from side B I ping side A, and then I verify the encapsulating packets and encrypting packets. Okay, in this case I am coming to PC1 and ping again my destination. At the first time 1 or 2 packets are missing, then the other packets are going through this tunnel and the packets are encapsulating and encrypting. Right now I am coming to router T and check the packet again. Okay, how much packet is encapsulating right now? Right now 9 packet is encapsulating and encrypting. Encapsulating, decapsulating. Okay, and also encrypting. Right now the IPsec is successfully configured on this tunnel. When I'm coming from PC2 and pinging PC1, is this packets or encrypting or not? So for this I should ping. And coming to router 1, I should check show IPsec crypto IPsec. Okay, 14 packets are encapsulating and encrypting, and also the IPsec is configured successfully through this tunnel. Right now each packet is going through this tunnel that is completely encapsulated and protected. So right now our traffic is right now secure and going in a secure manner through this tunnel. You can verify, and for example some commands for verification of IPsec: show crypto question mark. You can specify the IPsec policy, the key type, and the key that you added before, the session, and the identity, the IPsec, the map. For example, I'm coming and adding crypto key. Crypto key, for example, my public. Okay. For example, show crypto IPsec policy. Okay, here it shows that the encryption was the encryption algorithm. The encryption algorithm is AES, or Advanced Encryption Standard. The number of bits that we applied for this was the hash algorithm, the secure hash standard, the authentication method, special, and each group is 1536-bit, and group 5, and lifetime is here. You can specify lifetime as well. And the standard is this one. Okay, and we configured this one, the global IKE policy. Show crypto IPsec SA. It shows the number of packets that's encrypted and decrypted and encapsulated and decapsulated through this. Okay, when the communication is running through this tunnel. The crypto map is Cisco. Local address is 100.1.1.1, and the source, my source is 17216, and destination is this one, and the state is active. The map is this one. So show crypto session. It shows this session is up and active. My peer address is this one, port number 500, and my local subnet is this one, remote is this one, and this is the port number, and status also active. This is my specified traffic that I created through extended access list, and also active origin crypto map. So at the final, thank you for your watching, and wait for the next videos as